Morning once more. Our time is exactly 11:15. Like I said, we were still waiting for those who are still joining, but we can't wait any longer. We have to continue. So now, I think you can realize that. Okay, do you want to say something? Okay, ask if you want to ask something. Is there anyone who want to say something? Okay, so I was saying that I think you may realize that yesterday I sent an announcement on Blackboard indicating that you were supposed to write a quiz today, but we have postponed it until the 15th of March, which is Tuesday next week, to give you enough time to prepare and also to give time for those who have already joined us, recently joined us, time for them to just adjust. So, but anyway, if you have any question, you may ask before I start teaching. None. Okay. Now you will recall. Uh, so somebody's asking what is it the quiz is all about. I can't get the question. I think you are aware that you're going to write a quiz, and I gave you a scope that is only chapter 1, 2, and 3, and then we have agreed on that. So the other information I'll send them on Blackboard. I'll send them on Blackboard either maybe tomorrow or on Friday, so that you can be aware, because you're going to write it online, unlike the test that you were supposed to write it face to face. However, it has been postponed. I think you are aware of. So, but about the quiz, when, time, and all those information, I'm going to send them maybe on Thursday or Friday. So don't worry about that. You'll get the information. Okay. So if you recall, last time we were talking about the ARMA process. Remember, ARMA process, the combination of autoregressive and moving average process to become ARMA. So we were talking about the general one, ARMA PQ, then later we consider ARMA 11. In other words, ARMA 11 is the autoregressive process of order 1, a moving average of order 1 mixed together to becomes ARMA 11. So now we just check whether that ARMA 11 is it stationary or invertible. Then we find that it's stationary. That is why we ended up sorry, continuing to calculate the autocorrelation functions, because if it's not stationary, you're not supposed to calculate the autocorrelation function. You have to make it to be stationary first before you calculate the autocorrelation function. But however, we realize that it's stationary. That is why we managed to calculate the autocorrelation function. And before we calculated the autocorrelation function, we first calculated the autocovariances. The autocovariance that they are gamma 0, gamma 1, gamma 2, up to gamma k. Then later, after getting the autocovariances, then we calculate the autocorrelation functions. Autocorrelation functions is rho 0, rho 1, up to rho k. So now today we are going to just continue with the autoregressive moving average of order 1 1. So it's ARMA 1 1. But this time around, I'm going to show you how to calculate the weights. So the weights are in two forms. We have psi weights, and then we have pi weights. I'll show you how to calculate psi weights when you have been given a process, and then later show you how to calculate the pi weights when we have been given a process. So let's start. Okay. Okay. Just go to the blackboard. Whiteboard, sorry. Okay, now this lecture number 13, if I'm not mistaken. It's lecture 13. Okay. So we are still talking about ARMA 11. ARMA 11. Okay. Process. Okay. So we are talking about ARMA 11 where we are going to consider the weights. So like I said, we are going to calculate the weights. There are two forms of weights. We've got psi weights and pi weights. So we're going to consider psi and pi weights. So now, let's consider this ARMA 11 process defined by, let's say, xt is equal to by 1 xt minus 1 plus zt minus theta 1 zt minus 1. So this is ARMA 11, autoregressive of order 1 and the moving average of order 1. So in this regard, we just want to first calculate the psi weights. What do? The first thing to do is to take anything that contains xt to the left hand side. Okay. In other words, we're going to take phi 1 xt minus 1 to the other side. So this implies that xt minus phi 1 xt minus 1 is equal to zt minus theta 1 zt minus 1. So this is the first step. So the second step is to write the process in backshift operator. We just want to write this process in backshift operator. How do you do that? So you're going to have 1 minus by 1b, okay, xt, which is equivalent to 1 minus theta 1b zt. And remember, zt is a white noise with mean 0 and variance sigma squared z. Now, because we just want to calculate the psi weight, we must make sure that we make xt the subject of the formula. To calculate psi weight, you make xt the subject of the formula. But if you want to calculate the pi weight, we're going to make zt the subject of the formula. So, but anyway, let's start with this one, the psi weight. So let's make xt the subject of the formula. If you want to make xt the subject of the formula, you divide through by 1 minus phi 1b, both sides. 1 minus phi 1b, both sides. So you're going to get what? Xt is equal to 1 minus theta 1b divided by 1 minus phi 1b, then zt. Okay, xt is equal to 1 minus theta 1b divided by 1 minus phi 1b multiplied by zt. But anything within the brackets is equal to psi b. Now our space is very small. Can I go to the next page? Or maybe, can I just write it here? But 1 minus theta 1b divided by 1 minus by 1b is equal to psi b. Okay. So anything within the brackets is equal to psi b. So that means it's just the matter of just if anything within the brackets is equal to psi b, so we just want to cross multiply. We multiply psi b by 1 minus phi b, then equal to 1 minus psi 1 minus theta 1b. So what we are saying is, can I go to the next page, please?
Yes.
Okay, thanks.
Yes.
Okay. So we're saying 1 minus theta 1b, okay, divided by 1 minus phi 1b is equal to psi b. Okay. So it can multiply here, cross multiply here. This implies that if you cross multiply, you're going to have 1 minus phi 1b.
Sir,
Yes.
can you please go back? I don't know where you got side B is equals to 1 over. I mean, yeah.
This is the
That's
one.
hey.
Yeah.
How did you come to that step?
We are saying that is why there is bad there. Can you see that there is bad?
Hey, I see there is
Uh,
bar.
yes. So anything within the brackets that is equated to psi b. Why? Because we just want to calculate psi weight. Okay.
Oh,
So 1 over theta 1b over 1 minus phi 1b is equal to psi b, because our main idea is to find out the psi weight. So that's why we're using that expression there. Okay.
all right.
Okay, thanks. So now when we cross multiply, you will find that 1 minus psi 1b is going to multiply psi b, then which is equal to what? 1 minus theta 1b. Okay. And again, this psi b, it has been proven that psi b, it has been proven that psi b is always equal to 1 plus psi I b to the power I, where I is ranging from 1 up to infinity. You must know that if you are using psi b is always equal to 1 plus the summation of psi I b to the power I, where I is ranging from 1 up to infinity.
Sir, can
So
you please go back? Yeah, you are too fast.
I'm too fast, sorry. I'm here. I said we are going to use ARMA process, ARMA 11 process to calculate pi and psi width. Then I gave you the process there, which is ARMA 11. Then I wrote it in backshift operator. Then after writing it in backshift operator, because now we just want to consider the psi width, we just make xt the subject of the formula. So this is how we reach at the last step there. Xt equal to 1 minus theta 1b over 1 minus phi 1b multiplied by z. But because we want the psi weight, so anything within the brackets, then we equate it to psi b. So this is how we got into the last step there. Then when we continue, can I go to the next one?
Yes.
So when we continue to this page, obviously we equated 1 minus theta 1b divided by 1 minus phi 1b to psi b. Then when you cross multiply, it's going to give us this one after cross multiply. Okay, 1 minus phi 1b times psi b, which is equal to 1 minus theta 1b. So where psi b is known as 1 plus the summation of psi I b to the power I, where I is ranging from 1 up to infinity. So we are allowed to substitute psi b by 1 plus summation of psi I b to the power I, where I is ranging from 1 up to infinity. So we can substitute that one. So we can continue like that.
Sir,
Mm.
sir,
Yes, yes, I'm listening.
yeah, if I could ask, how did they arrive to know that? How did they prove? Since you said they proved that psi of b is
Psi
equals
of
to,
b.
yeah, how did they come about
Yeah,
to
yes.
conclude?
In mathematics, there are things that you have to apply that have been proved before. So we take that application and we use it in our calculations. So in this regard, it has been proved that psi b is equal to 1 plus summation of psi I b to the power I, where I is ranging from 1 up to infinity. So we don't want to just go back and try to prove that psi b equal to that. So in this course or in this module, we just want to apply that one as it is. As long as you know that psi b is equal to 1 plus summation of psi I b to the power I. So we just want to apply that. There are many things that you have to apply them rather than just proving where did you get it from and all those stuff. Okay.
Sir,
Mm.
sir,
Yeah, yes, I'm listening.
sir, what are we looking for here?
Yes, I explained from the beginning. I said we want to calculate the pi weights and the psi weight from the model. What type of model are we talking about? It's ARMA 11. So we have been given ARMA 11. You have calculated the autocorrelation functions. You have calculated the autocovariance functions. But now I want to show you how to calculate the weights of that particular process. The weights we are talking about here is psi weights and pi weights. So now this step where we are now, I'm showing you how to calculate the what? The psi weights. So this way we are.
Okay, thank you.
Okay. So now let's continue. So we are saying that 1 minus phi 1b times psi b is equal to 1 minus theta 1b. So, but psi b is equal to 1 plus summation of psi I b to the power I. So we just want to substitute that psi b by 1 plus summation of psi I b to the power I. So we are going to get what? 1 minus phi 1b. Okay. Then you must substitute that psi b by what? By 1 plus. So you can agree with me that 1 plus summation of psi I b to the power I, where I is ranging from 1 up to infinity, can also be written in this format. Psi, sorry, can be written as psi 1 b plus psi 2 b squared plus psi 3 b to the power 3 and so on. Okay, which is equivalent to what? 1 minus theta 1b. Are we together? Do you agree that 1 plus summation of psi I b to the power I, where I is ranging from 1 up to infinity, can be written as 1 plus psi 1b plus say 2b squared plus say 3b to the power 3 and so on. Do you agree? Okay. So now we are having that expression. So we just want to open the brackets. Okay. So 1 minus phi 1b supposed to multiply the rest there. So that we can open the brackets. What did you get? You're going to get 1 multiplied through there. You're going to get 1 plus say 1b plus say 2b squared plus say 3b cubed. Okay. Then you take minus phi 1b, you multiply through again. You're going to get what? Minus phi 1b minus phi 1 say 1 b squared. Okay. Minus phi 1 say 2 b to the power 3. Again minus phi 1 say 3 b to the power 4 and so on. When you go like that, then you equate it to 1 minus theta 1b. Are we still together? Take 1, we multiply through, get the expression, then you take minus phi 1b multiply through, then that's what we get there. So now you can see that here you have got psi 1b, okay, and here you got minus phi 1b. So you can get the common factor there. Are we together? So you're going to get something like this. This implies that 1 plus. So from psi 1b and minus phi 1b, you can get the common factor, which is what? B, isn't it? So it's b, open brackets, psi 1, what? Minus phi 1. Are we together? Okay. You do the same for this one. Do the same for this one. B squared and b squared there. So you have to find the common factor as well. Then you set plus b squared. Open brackets. Say 2 minus phi 1. Say 1. Okay, you do the same for b cube. Do the same for b cube there. You're going to have a common factor which is b to the power 3. Open brackets.
Sir, can
Yes.
you repeat the last step?
The last step.
Yeah.
I'm saying if you can check the second step from the last, if you check, we've got 1 plus I 1b plus I 2b squared plus I 3b cubed and so on. Here, if you check b, this one psi 1b and this one phi 1b, you can find the common factor, isn't it? Common factor is what? Is b. So that's why we're having b here. So you're going to be left with psi 1 here and then minus phi 1 there. So that's why we're using something like this here. Okay. The same applies to b squared. You are going to take this and this. You find the common factor, which is what? B squared. If you find the common factor, so you're going to be left with what? Psi 2 minus phi 1 psi 1. So that is what we have. Do the same for b cube. If you check this statement here, and this one here, so you can find the common factor as well.
Morning, sir.
Morning, ma'am.
Morning. Sir, may you please elaborate on something on the second line?
From the bottom or from top?
Where, no, from the top. There's something that confuses me when you introduce the, is it weight? I'm not sure if I'm pronouncing it correctly.
Oh, okay. So the
Yes,
second step,
yes, the
the
second step.
where I said where side B equal to blah blah blah.
Yes, there's something I want to understand. Is that always going to be the way it is, or it's according to each and every single process that you give us?
Yes, if you are calculating the weights, you must always know that side B, which is
Okay.
this one, it's always equal to this one. Okay?
Oh,
Like
okay.
I said it has been proven that side B is equal to that. We don't want to go into that. But the issue is side B is always equal to 1 plus summation of that. Okay? So especially when you are calculating the side width, it will help you.
So, sir, on you see on the first step from the
Mm,
top,
mm,
whenever after we calculate everything and we introduce the backward shift, whatever, we should always
mm.
make sure that we equate our sign B to something else.
Yes, of course.
Okay.
Of course. You have to. You have to. That is the
Okay.
procedure of finding the weights.
Oh, okay. Thank you,
Okay.
sir.
Okay, you're welcome. Coming back to our calculations, I was saying that for B cube, this one, and this one, you find the common factor, which is B to the power 3. That is why I take it out here, open brackets, then side 3 minus phi 1, side 2. Yes, I think it's correct. Then you can just go like that, okay, until you equate it to
Sir,
1 minus, yes, beta
the
1.
last B there, is it to the power 3 or to the power 0?
Yes, power 3. So you know that my handwriting as always it's not that good. It's 3. It's b to the power 3. So then you equate it to 1 minus theta 1b. So now, so you have got this, the expression on the left hand side and the other one on the right hand side. Okay. So you are going to equate 1 and 1 and equate those expressions that having b and b. In other words, what we are doing, we are going to equate the coefficients there. We're going to equate the coefficients there. So how do we do that? So this implies that you can equate 1 and 1. Remember, we have got 1 on the left hand side there. We have got this one and another one here. Okay, because they are constant, you can equate them together, 1 and 1. Then later you have to equate those that contains b. Okay, in other words, you're going to equate this one and this one.
So
Okay, yes.
I think I missed something there uh, when you're busy collecting the one that are the same. I don't know what happened to the is it psi or what? That one which is of the power for the B.
Yeah, that one, isn't it? We're continuing like that. You can just leave it or include it if you want. Remember, it's up to infinity. Okay, it's up to infinity. We're not allowed just to put all the values or variables. Some of them we just generalize. We say that if you just continue like this, you're going to get something like that. So, but in this case, I just left it out because already I got what I wanted. So that one, obvious, if you want to edit, you can just edit there. So the question is, we are going to edit what? Because in that regard, we don't have anything. So, but anyway, if you want to edit, you can edit there. So, and continue like that. So obvious is still continuing. You can just add that one or leave it. It's up to you.
Okay, so I think I understand.
Okay, then. So we equated 1 to 1, then you are going to equate those that contains b's. Because we don't have any space there. Okay, I'm saying we're equating 1 and 1. Equating 1 and 1. Okay, that's the first thing. The next one, you have to equate b, those that contains b, which is this one. So in this regard, it's psi 1 minus phi 1 and minus theta 1. Equate psi 1 minus phi 1, equate T2 minus phi 1. Let me just go back so that you can see it lower. You see, psi 1 minus phi 1. Oh, you equate it to theta 1, sorry. You equate it to theta 1, sorry, not phi 1.
It's teacher one.
Yes. Equate to theta 1. Okay. You do the same for this other one. For this b squared, you have got b squared here, but here you don't have b squared. So it's 0, isn't it? So you are going to equate this to 0. Psi 2, psi 2, phi 1 minus, what is that? Psi 2 minus phi 1, psi 1. 2 minus psi 1, psi 1. Okay, this one is equal to 0 because we have nothing here. Because we don't have b squared here, and we don't have b to the power 3 here. So we're going to equate them to zeros. So again, this one, you equate it to 0. So it's psi 3 minus psi 1, psi 2, I think. Equate it to 0. Psi 3 minus, okay. So it's psi 3 minus phi 1, psi 2.
Oh, it's
Phi 1,
plus.
this one, this is the one that we want. Psi 3 minus phi 1. Yeah, I think it's like this one. Are we together? Just ask before we proceed if you have any question. The first one,
Yeah,
we
we're
equated 1 and
together.
1. Okay.
Sir,
Psi 1 minus
sir,
phi 1. Yes.
what you're saying is that
Yes.
we are going to equate the coefficients up until to infinity.
Yeah. Up to we generalize it. We're going to generalize later. You will see that.
Okay.
So now, psi 1 minus, remember, we just want to find psi weight. Okay. So this implies that. So you are going to have psi 1 here, which is equal to phi 1 minus theta 1. Are we together? So in other words, on the left hand side, we are left with psi 1. We take phi 1 to the other side. So that is why it's positive there. Then minus theta 1. I think we are together there. Do the same for this one. Psi 2. Okay. It's equal to phi 1. Psi 1. Okay. But psi 1, you have already calculated it up there. So you can substitute and get what? Phi 1, open brackets, phi 1 minus theta 1, close brackets. All together. Okay. Proceed like that. The third step. So it's psi 2 equal to phi 1 psi 2. And side 2, you have already calculated it up there. So you can substitute it. So you get psi 1 squared. Psi 1 theta 1. Okay.
Oh,
If
sir.
you get,
The first one, where is the negative?
the first one, the first step,
Uh,
the one that I equated 1 and 1.
yes, I agree. No, the second. I agree. There
The
is
second one,
minus A.
yes.
There is,
What's the problem?
you said it implies that psi 1 is equals to psi 1 minus psi 1. And what is the negative?
No, isn't that when you take it to the next, to the right hand side, you have to change sign. This one. When you take it to the right hand side, it's supposed to be positive. You see that one?
Yes.
And this one remains because it's a minus theta. This is the one.
Okay. So it's not 0.
It's going to be 0 because we have psi 1 minus phi 1, which is equal to minus theta 1.
Oh, all right, all right.
Then that's it. So the same applies to the second step there and the third step there. So you can see that now.
So on the
Yeah.
Sir,
on the
the
third step,
third
isn't
step is
it side 3?
There's somebody who unmuted the
side
mic.
3.
Please mute your mic. Okay, thank you very much. Come again. Question?
The third step is side 3. You wrote side 2 instead of side
Oh,
3.
yes. Thank you very much. Yeah, I saw it. Thank you. Side 3. Okay, so you can see that we have side 1, side 2, and side 3. So from the first step there, where we equated 1 to 1, you can just assume that obvious side 0 will be equal to 1. Remember, in the partial autocorrelation function, you remember that we said row 0 is always equal to 1. So in this case, you can just assume again, from that knowledge of partial autocorrelation property, so psi 0 can be equal to 1. But psi 1 is equal to phi 1 minus theta 1. Psi 2 is equal to psi 1, phi 1, open brackets, phi 1 minus theta 1. And then psi 3 is equal to phi 1 squared, open brackets, phi 1 minus theta 1, close brackets. Are we together? So therefore, let's generalize this. We have psi 1, psi 2, psi 3. So if you can just go like that, you end up getting psi j. We just want to generalize and have our own equation. So psi j minus phi 1, what? Remember here we have got phi 1, psi 1. Psi 2 minus phi 1, psi 2. Psi 3 minus phi 1, psi 2. What about psi j? It's going to be minus phi 1, what? Psi what? You can tell me. Say
J
what?
minus 1.
J minus 1. Thank you very much. Which is equivalent to 0. Okay. Then, if you want to write psi j, the subject, the formula, you're going to have psi j will be equal to what? Phi 1 psi j minus 1. Okay. If you go like this, so here you're going to be having phi 1 to the power what? J minus 1.
1.
Yes. Phi 1 minus theta 1. So this is the formula where J now is ranging from 1 up to infinity. So J is not starting from 0. J is starting from 1. However, we have a property of psi 0, which is equal to 1 there. So this is the equation that you can use to calculate psi j.
Sir.
So in other words, from this you can calculate what? Say 1, say 2, say 3, and so on.
Sir,
Are we together? Yes.
why are you using J, not I?
Where are we using J?
Yes, why J instead of I?
Oh, that one is not a problem. You can just use I. There's no harm on that. You can use I instead of J. Isn't that myself?
Oh,
Maybe I chose J because I like it. But you can take I if you want. It doesn't change anything. It's fine.
Sir,
So now
so
you understood. So
sir,
yes.
if you are given a process, are we going to write it in a ship operator, or we are just going to substitute to the equation?
Yes, that's a good question. So there is somebody who unmuted the mic and is disturbing us. So if you have been given a process, if that process look alike to this one, the one that we've used here, armor, if that process is like this one, in other words, if you are using maybe the real numbers, okay, for example, here maybe instead of having phi 1, you are having, let's say, a half, okay, and here you are having let's say 2. Here instead of theta you're having 2, okay. Here instead of having phi 1 you're having a half, but here is a minus and here is a minus. So this process, they look alike, so you're allowed to use the formula. You're allowed to use this one. You get what I'm saying? I'm saying here if instead of phi 1 you have another value which is a half, instead of a phi 1 we have a half, but the process just say xt minus half xt minus 1 is equal to zt minus 2 zt minus 1. You see that this process is the same as the one that we use when we are using the general parameters. So you are allowed to use what we have produced here. But if you have got an armor 1 but instead here you are having a minus, you see now, and here you are having a positive, yes, minus, yes, positive. So you are not allowed to use what we have got it here because it can mislead you. Okay, so in this regard you have to start afresh. You have to start afresh and start by finding xt, take it to the left hand side, find right backsheet operator. If you want to write to find the psi weights, you just make xt the subject, the formula, and so on. The same applies if you have got armor 1 2, but this one is armor 1 1. Let's say you have got armor 1 2. So in other words, what does that mean? Sorry, armor 1 2. What does that mean? It means that autoregressive of order 1 and a moving average of order 2. And remember, this one is autoregressive of order 1 and a moving average of order 1. So you can use the general formula that we created. So you have to start afresh. In other words, your process will be xt, let's say, equal to phi 1, xt minus 1 plus zt, let's say, minus theta 1, zt minus 1 minus theta 2, zt minus 2. You see this one? This is the armor 1 2. It's different from armor 1 1. So you can use what we've generalized using armor 1 1 to calculate armor 1 2. So you have to follow that procedure. This procedure is very important. You have to follow it step by step. So that means while we are doing it, you have to know what we're doing so that you can apply it later in different processes. I think I've answered your question. Unless if you have
Say,
follow up. Mm,
say.
mm.
So what you're saying is that okay for us when we are using the back operator, when we want to take the auxiliary equations, the auxiliary
Mm.
equations is just for us to find to check if this process is stationary or casual, and
Um,
on equating because there I saw for for that B. We know if we have a moving average on the part on the
mm,
other one, which is the moving
yeah.
average
Mm.
two, ne, that
Oh,
means we are
okay.
going to get two big. Mm. Okay,
Yeah, yeah,
you
yeah.
can.
You're cutting. Can't even hear you.
Okay, so I was
Mm.
saying if you like the equation which you just wrote now, which is
Yeah, yeah.
RM
Arma.
arma 1 2, ne.
Yeah,
Yeah,
this
on
one.
that
Yes.
one, I agree. We know that if we introduce the back operator there, we're going to
Mm.
find the auxiliary, which is the
Mm.
one which is going to help us to find the value of B1, B the two
Yes,
B's.
yes, yes. I
So
understand what you.
so we're going to use the auxiliary cable only to find the B's, and they are telling us the causality, and they are also the constant when we are using this method to equate the two equations.
Yes, but remember, when you want to find the causality or invertibility, I explain how do you do that. You do what I've explained to you only in that regard. So here, this is the process. You want to find the weights. So it's the matter of just writing it in backsheet operator. Then you, if you want to find the psi weight, make xt the subject the formula. If you want to find the pi weight, make zt the subject the formula. It has nothing to do with the causality or invertibility.
So when we are given like on the first equation, like when we were saying phi phi like that one phi one
This
one
one.
minus theta one b, ne, we used
Yeah, this one.
oh I see now we are not using the b's. I see sir.
You see? Okay. Okay, anyway, but what I was explaining, did you got it? If you have got two different processes, you can't use another, like what we did here in ARMA 1.1. We created our equation that can help us maybe to calculate the psi weights. But if you have got a different process, like for example, ARMA 1.2, you can't use what we've generated to calculate the psi weight of ARMA 1.2. It's what I was trying to explain. So therefore, in that regard, you have to start from the beginning. You find the backshift operator, then you make xt the subject of the formula, then you go step by step, like what we have been doing. Where side b is equal to that, you go step by step until you reach the final one. So can we go to the pi weights now because we are done with the side?
Manier,
So, sir,
Hmm.
sir,
Yes, 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 you are welcome.
so if you are given ARMA 1.1 process, but with different signs, are we still going back from backsheet operator, or we are just going to use the derived formula?
I think you have to go back to backshift operator because do you know, or maybe you can change the sign. I don't know because I've never done that. So the issue is the sign. All the sign must be the same because we use the negative and the positive, for example, on that one to generate the equation there. So if the signs now are different, so obvious down there in the expression, you are going to get the difference equation. You get that? So, but if you still use the same equation, while up there the signs are different, you're going to get the wrong answer. So that means to be in the safe side, if the signs are different, it's better to
Okay.
go step by step. And remember, that doesn't mean that in a test, in an exam, I'm going to give you the same as this one. I might give you the different one. So you have to know how to calculate them, how to generate that equation, how to generate that psi weights. Otherwise, if you memorize this one, this last equation there, and I gave you another process, let's say ARIMA 1, 2. So that means now already you won't be able to get it if you use that equation that we've created there. So I can advise you to just go step by step and you know those things. Any question?
Manier,
I
yeah, I have a clarity of what's going on, but I want to understand what are we actually doing? Because yeah, I'm kind of like lost in what are we actually doing? So that I don't know, but I do
from the
understand what.
beginning, or
Yeah,
you are saying from the beginning on for
like,
today?
like for this,
For this, okay.
what
I
what
think I
what
explained.
what is
Yes,
the
let me just
reason, the main reason behind
yes,
this to
yes,
understand
the
the
reason
total
behind here.
lightness?
Remember there is a we're dealing with the time series here. So in the time series processes, we have to check whether the process is stationary or not. So if it's stationary, so you can continue to analyze the process. Okay. But if it's not stationary, you can't proceed. So that is why at the first place, you have to check whether it's stationary or it's not stationary. This is very important. After getting that, is then that you calculate the autocorrelation functions. Autocorrelation functions, it helps us to identify the model. ARMA 11, ARMA 21, you get them from autocorrelation processes. Okay, sorry. And then, and some, in other cases, you can't calculate the autocorrelation function without autocovariances. That is why we included the autocovariances. That is why you have a process, you calculate the autocovariance functions, you calculate the autocorrelation functions. Now, after doing that, you just want to see the weight of the model. How do you check the weight of that model? To calculate the weight of, to check the weight of the model, that is where we introduce the pi weights and the psi weights. Remember, in the autocovariances, we were using gamma 0, gamma 1, gamma 2, and so on. In the autocorrelation function, we're using rho 0, rho 1, up to rho k, and so on. But here, to check the weight of the model, we use psi and pi weights. That is why now, today, we are in this procedure of finding phi's and the psi's and the pi's. Just because it's just a matter of finding the weight of the model. I don't know whether I explained the way you understood it.
Okay. Where is
Yeah.
this process applicable, like in real life?
Eh? In real so in real life, time series is very important. Time series, we are dealing with time. That is why at the beginning I said it's the observation. Time series, the observations of time, data collection over time. Like when the rain, it's raining. It can rain the whole year. It can rain maybe certain months. So we collect that readings and check. How can we predict the future? Is it going to still rain, or is going to rain occasionally, or it won't rain, or it's going to have more rain also, or what? This is where time series assists us. So that is
Aibu,
why,
say,
yeah.
uh, Ganti, isn't the weather predicted by climatologists?
Even yes, but in our case, using the data, we can just predict that in the next 2 years we might have a lot of rain or you can't have a lot of rain, using what we have, using the data that we have to predict the future, time series person can use that instead of
Or to predict the currencies. If you're doing forex, you
yeah,
have
or to predict the currency. There are many things that you can predict anyway. I'm just giving you the example. But anyway, I think we are out of our subject today. So I think that one can be for another day. Yes, it can be for another day. So I can explain it better. Especially we'll understand this one when you want to continue with time series in the honors. Because this is where you are going to deal with the real things there, the real data. Here, there is a lot of theories. There is a lot of theories in such a way that without applying it, it won't be, it doesn't make sense. So, but anyway, we are just preparing you. If you want to do honors, if you want to do projects, you must understand what we are looking for. Because you can't just do project without knowing what is a partial autocorrelation function, without knowing what is an autocorrelation function. So it will be very difficult for you. You start from the theory, then you go to the practical. It's then that you can understand what are you applying. So can you allow me to continue? You're so quiet and you ask a question. So may I continue?
Yes, sir.
Okay, thank you very much. So, like I said, we calculated the sideways. Let's go to the pi ways. This is the same procedure. If you knew the first procedure, you can also know this one.
I'm Batman.
So okay, let's go. So it's about pi ways now. The weight of the model. Yeah, pi ways. Okay. And remember, we're still using the same process. ARMA 11. Process, okay? So which is defined by xt equal to by 1, xt minus 1, zt, theta 1, zt minus 1. Okay? So now, again, you take it to the left-hand side, you're going to have 1 minus, take a backsheet operator, so it's the same thing. Okay. xt, which is equal to 1 minus theta 1, b, zt. And remember, I said if you want to calculate the psi weights, you make xt the subject of the formula. But if you want to calculate the pi weights, you have to make zt the subject of the formula. So in this regard, because we just want to deal with the pi weights, make zt the subject of the formula. So you're going to get what? Zt equal to 1 minus by 1b, 1 minus theta 1b, xt. Are we together? Okay. Now, but because now you're dealing with the pi weight, but 1 minus phi 1 b over 1 minus theta 1 b equal to pi b. Okay. So then from there is cross multiply. This implies that 1 minus theta 1 b pi b is equal to 1 minus phi 1 b. Okay. Where in this regard, again, pi b would be equal to 1 minus the summation of pi I b to the power I. where I is ranging from 1 up to infinity. Okay, so you can substitute like what we did before. So we are going to have 1 minus theta 1b, okay, 1 minus pi 1b by 2 b squared by 3 b to the power 3 and so on. Then you equate it to 1 minus pi 1b. Still what? Still together. Then from there you open the brackets. Simple arithmetic. So you're going to get what? 1 minus pi 1 b by 2 b squared by 3 b to the power 3 minus theta 1 b plus theta 1 pi 1 b squared plus theta 1 pi 2 e to the power 3 plus theta 1 pi 3 p to the power 4 and so on. Then you equate it to 1 minus pi 1 b. We're still together. So then again you do the same. Group those that contains b together. Otherwise this one and this one, and then this one and this one, this one and this one, and so on. Okay. So I have to go to the next page. Can I?
No, sir.
No,
Okay,
no, 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 sir.
no, it's fine. It's fine. So I can group them together. Okay. You will tell me when we are done, isn't it?
I'm done, sir.
Oh, you are done.
Yes.
Okay. Okay. So let me just go to the next page. Okay, this equivalent, sorry, let me just use this one. This is equivalent to 1 minus b open brackets. I think it's minus pi 1 minus theta 1 plus b squared. You will correct me if I'm not writing the correct thing. Pi 2 plus theta 1 pi 1 plus b cube pi 3 plus theta 1 pi 2. Okay, plus and so on. Then equate it to it 1 minus pi 1. Is it correct?
Sir,
Yeah.
I think the negative pi there on the B is
For
supposed.
which one? Yeah,
Yeah, I think it's
yeah.
supposed to be positive.
Supposed to be positive.
Yeah.
Yes.
Let me see. Because remember, we're taking this one and what? And this one. Both are negative. Negative theta 1. Yes, negative pi 1. Take B outside. Is it not a negative pi 1, negative theta 1? Hmm? It's not this one. And this one.
No,
Oh, maybe yeah. Oh, for negative B. Ne?
yes.
Yes, yeah, you're right. You're right. Yeah. Yes,
If he
positive.
multiplies this two, it'll give him a what the fuck?
Isn't it? Yeah, I got what you're saying. Well, oh, it's what you're saying. You're saying 1 plus B, ne? It's what you're saying, isn't it? It's still there. So everything now it's okay. It's fine.
Yeah.
Okay. So then from there you equate the coefficient. In other words, 1 with 1. Okay. And then minus pi 1 minus theta 1 with what? Minus pi 1, isn't it? Okay. Then minus pi 2 plus theta 1 pi 1 with a 0. Next one is minus pi 3 plus theta 1 pi 2 and a 0. Okay. So this one can just say is pi 0 equivalent to 1. And this one can say is pi 1, which is equal to pi 1 minus theta 1. All together. It's true, ne? Pi 1 is equal to pi 1 minus theta 1. Eish, making things bad now. Okay. Now the next one is pi 2 theta 1 pi 1. Next one pi 3 theta 1 pi 2, isn't it? Okay. So here can also be equal to what? Theta 1 pi 1 theta 1. Okay. Here theta 1 squared by 1 theta 1. Okay. Then you can generalize again. Pi j or I plus theta 1 pi j minus 1. Then pi j theta 1 pi j minus 1. Okay. Theta 1 to the power j, open brackets, by 1, theta 1. So this is the general one for j ranging from 1 up to infinity. So, but this one is a general equation for what? For armor 1, 1 there. So you can use it for armor 1, 2. Can you use it for armor 2, 1, and so on. Any question before we go to another example?
Still copying, sir.
Okay. So this is how you calculate the pi weight and the psi weight for armor 1, 1 process. So you can apply the same procedure for armor 1, 2. You can also apply the same procedure for armor 2, 1. You can apply the same procedure for autoregressive of order 2. Same procedure for moving average of order 2 to calculate the psi and the pi weights.
You can move, sir.
Okay. So now, let's do this example. It's on page 34 for those who are having the lecture notes. Example 3.10.2. But anyway, I will write it down for you. If you don't have it, let's say it's an example. 3.10.2. It says find let me say find the first four psi width. And the first 4 pi width. For what? For this process. Armor 1, 1 given by xt equal to 0.5 xt minus 1 plus zt minus 0.3 zt minus 1. And remember, zt is a white noise with mean 0 and variance sigma squared z. So, you know where to start. You have to start by finding, to check whether the process, let me say, check whether the process is stationary. Stationary and invertibility. Stationary invertible. Then later you find this. This is number B. find the weights. I don't want you to go to the autocovariances and autocorrelation functions.
The deal was that if I win the Hunger Games, I get to live
What
the
is
rest of my life
happening?
in peace. But now,
Kabelo.
So just calculate, check whether the process is stationary and check whether the process is invertible. Because you have to check two things in one. Because that process is ARMA 11. It's autoregressive of order 1, moving average of order 1. Check stationarity in autoregressive, check invertibility in a moving average process. While you've done that, just go to calculate the 4 psi weights and 4 pi weights. Just want to see the, or maybe just, because it's too long, let's calculate the 4 psi weights, this one only, because it's too long. But on your own time, you can just continue and calculate the 4 pi weights. So let's calculate the first 4 psi weights. So the first 4 psi weights we're referring to, you find psi 0, psi 1, psi 2, and psi 3. Are we together? When I say find the first 4 psi weights, I'm referring to psi 0, psi 1, psi 2, and psi 3. Don't start from psi 1, psi 2, psi 3, and psi 4. So you start from psi 0, then you give the other 3. Because there are those who can start from psi 1 and give me the other 3. If the question says find the first 4 psi weights, start from psi 0, then psi 2, psi 1, psi 2, psi 3. I think it's clear.
Sir,
Yes.
is psi 0 or pi 0 always equals to 1?
Yeah, it's always equal to 1. But anyway, when I say the first 4, you must start from psi 0 there. It's always equal to 1.
So
So
it
say
means
if
according to
it's
math,
not
that's correct
stationary.
if it's 4 marks.
Come again?
Let's say if it's 4 marks for those
Yes.
bits. So it
So
means we
that means
continue
each and
1
everyone
mark.
is having a mark there like this.
All right.
So say if it's not stationary.
Oh, you have to make it to be stationary before you calculate the what called the autocorrelation functions. But in this case, I don't want you to calculate the autocorrelation function. I know that thing is stationary, isn't it? Isn't it? The process is stationary, isn't it?
0.8.
And then
Yes,
it's invertible. And you have to give me the reason.
the absolute value of fire 1, which is the absolute value of 0.5, is less than 1.
That's true. Then invertibility,
Yes, it's invertible.
the same thing.
The
Okay,
absolute
so
value.
now, okay, I got it. So it's stationary and also invertible.
Yes.
So now calculate the sideways. So can you see the relationship between this ARMA 11 that we're using now and the ARMA 11, the one that we've been using before? Can you be able to use the equation that we created? So I think in this regard, you can use the equation that we created. They're the same. The only difference is that On that one, we were using parameter, constant parameters. But here we're using the real numbers. But the signs are the same. The process is the same also. Now, you can use that equation to find psi 0, psi 1, psi 2, and psi 3. Then later, you can just use the same process following the procedure that we've been doing and see whether you're still going to get the same answer. So you can just do that later. But for now, I need the values of psi 0. Obvious psi 0 is 1. The values of psi 1, psi 2, and psi 3. Yeah. Come again.
Someone's mic is on.
Please mute your mic. So we're left with 4 minutes. So we must make sure that before time up, you have the solution. Before time up, you're supposed to have a solution.
Psi 1 is equal to 0.8.
0.8. Do others agree with that? Guys, do you agree? Do you agree? I need the answer. Different answers.
It's 0.8, sir.
Remember to find those parameters. Supposed to have a strategy. So phi 1 is what? Phi 1 is what? Psi 1 is what? You can tell me.
0.8.
I'm not saying psi 1, you are saying 0.8. And then psi 0, you're saying is 1. Psi 2. Do you all agree?
0.4. Yes.
No, that's not true. I'm just writing them, but it's not true. You start by finding, okay, who can tell me what is phi 1? Okay, tell me what is phi 1, and then you tell me what is theta 1.
Phi 1 is 0.5, theta 1 is 0, negative 0.3.
Theta 1, is it positive or negative?
Positive.
It's positive. Theta 1 is
0.3.
positive 0. Yeah. So when you use these ones, are you getting 0.8?
Made a mistake, sir. Let me try again.
The time is up. Remember, psi 1, okay, it's equal to phi 1
Phi 1 is equals
minus
to
theta 1.
0.1.
Are you sure? Are you sure? It's 0.5 minus 0.3.
Sir, I have a question.
Yes. Yes.
Sir,
Mm.
so that's 0.3. We don't take it with the negative there.
I think last time I explained, unless if some of you were not listening, I was saying if you want to use the parameters from the process, okay, there is an autoregressive process and there is a moving average process. To check the parameters of autoregressive, let's say this one. So remember, it's phi 1 because it's parameter of autoregressive. So phi 1 is equal to 0.5. You know why? Because already here, xt is the subject of the formula. We ignore the rest for autoregressive. Then we make xt
Okay.
the subject of the formula. It means phi 1 is 0.5. Correct. Okay. Coming to the moving average, you do the same. If you want to find the parameters, you do the same. You ignore the x's for the autoregressive process and consider zt. Then zt here is zt minus 0.3, zt minus 1. Then equivalent to 0. So you make z the subject of the formula is going to be 0.3 zt minus 1. Therefore, the parameter theta is going to be 0.3, not negative 0.3. It's what I said.
Okay, sir. Thank you.
Sir,
So you have to be careful with that one, especially when you are dealing with the parameters there.
sir, sir.
Yes. Mm.
Yeah, did they give you the answer of psi 1?
So it's going to be 0.2.
Sir,
Yeah.
in short, can we say when we are in an armor process, when we are testing the side of the moving average, you always negate the sign of theta 1.
Yes, especially when we want to check the stationarity and invertibility. So if the issue is you just forget about that other process. If you are dealing with another one process, deal with that process, forget about the other process. So you'll get
Oh,
the right
okay. So
thing. Hmm. So I think we can stop here.
So,
Just go
sir,
and use that procedure and check whether you're going to get. Oh, psi 1 is equal to 0.2. Psi 2 is what? Psi 2, according to my calculation, is
0.1.
0.1. Yes, 0.1. Psi 3?
0.05.
Yes, 0.05. You see. So just go and verify whether it's true using that long method. The one that you have to write it in backsheet operator, write xt, the subject, the formula, then until you get the answer and see whether you're going to get the same thing. So I think
sir,
we can stop here. So today we want to have the tutorial. We had a tutorial
0.1.
for what? For
So, sir,
science?
if you don't have tutorials, can we come and consult in your office tutorial time?
No, for tutorial time I don't want to see you
Now,
here. I rather maybe tomorrow on Friday. Ne? I
okay, no.
will teach a little bit, then later I'll give you time to ask questions.
So you don't
Together,
allow contact consultations.
for now, no.
All right.
The COVID is not still, it's not there.
Sir,
Hmm? Hmm.
can I ask something on something we did previous on the PACF?
Um, Can I stop the recording?
Yeah, it's fine. You can.